Hello again and welcome to the third video of this tutorial. In this video, we will see how to use the simulator to simulate the data source for this project. This simulator is a PackML simulator developed by Tom from Libre. And as always, let me give you an overview about PackML. PackML, or Packaging Machine Language, is a programming standard defined by the Organization for Machine Automation and Control, or as known by OMAC, in conjunction with the International Society of Automation, ICA. The primary objective of PackML is to bring a common look and feel and operational consistency to all machines that make up a packing line. PackML has three main aspects of its implementation. First, standard set of terminology. Second, state model. And the third is set of tags. Let's take a look at some common terminology about how the machine is broken down that can help you navigate a PackML program. Here is the term unit, which represents an entire machine. For example, a filler machine, wrapper machine, etc. State. The state term represents the currently active machine condition. For example, starting state, execute state, clearing state, and so on. The state command, which represents an action that triggers a state change. For example, operator presses a button, machine responds to an alarm. The motor, that represents a set of states and state commands that carry out a process. For example, the production mode, the manual mode, the maintenance mode, and so on. The second aspect is the state model. The state model defines the top-level control of the machine. It coordinates the operation of the machine's components to execute different actions and react to whatever is happening. For example, when a PackML machine is starved due to an external process condition, the model sends the machine into a suspending state. In this suspending state, all the machine's actuators execute their actions to pause production. Then, when the machine has product again, the model sends the machine into an unsuspending state to resume production. The last aspect, which is tags. Tags are broken down into three types: command, status, and admin tags. The tags define how the program communicates with other machines in the packaging line and with high-level control systems. Command tags are used by the machine to make a change, while status tags are written to by the machine to be used elsewhere. On the other hand, admin tags have data to be used for analysis, such as stoppage time, stop reason, and units produced. Let's practice. For today's video, we'll just see how to use the PackML simulator, but in the next video, we'll get our hands dirty, and I'll show you how to use the platform to model and simulate a packaging machine, or even a packing line. For now, let's see how to interact with this simulator using an MQTT client like this one, MQTT Explorer. In the last video, I showed you how to connect to the MQTT server using this MQTT client, and we added some topics. For now, let's understand the structure of these topics. Here you see the structure, PackML, sim, and you find under it line 01. These names are coming from the Docker Compose file, and you can change them as you want. You need just to restart the PackML simulator container when you do that. PackML represents the ICA 95 model site name. Similarly for sim and line 01, which represents the name of the area and the name of the line respectively. To learn more about this, refer to the first part of this standard, and I highly recommend you to take a look on the other parts of the standard as well. And at least the first part that contains the terminology to have a better understanding of what we're doing here, as everything we're doing or we're going to do is based on this standard. Let's get back to the MQTT Explorer. Under the line, we find the tags I told you about. Admin tags contain data to be used for analysis, while status tags are written to by the machine to be used elsewhere. To learn more about this, go back to the repository. You'll find everything you need to know. As you see, the current state of the machine is stopped. If we get back to the state model, we see that there are 3 states that the machine goes through before getting into the execute state. How we do that? Let's scroll down. We found a topic template that we need to publish to in order to get the machine into a specific state. Let's put the machine into the idle state. In the MQTT client, type the topic as described in the repo, which is PackML/sim/line01 and the values that this topic can have are 0 or 1. If we hit publish, we'll see that the current state is changing. Now the machine is in the idle state, so we need to issue another command to send it into the execute state. Similarly, we need just to replace the last level of the topic to start. And again, we see the current state is changing. It is straightforward. Just follow the state model to put the machine in any state you want. Take your time and play with this simulator. And if you're not familiar with the PackML standard, I'll leave you some resources in the description below. This is it. See you in the next video.